today we have Kahn and Dario Rodighiero talking about collecting visualizations in the time of coronavirus. So without further ado, I will turn it over to you guys.
So thank you. I want to thank Aditya, who was kind enough to reach out and ask if this was going to be possible, and everyone else, Joe and Wendy at BostonCHI. It is a little different. I'm actually in France, and Dario is in Italy, but both of us have been in the Boston area for significant amounts of time, and so we're very familiar with BostonCHI. I'm really happy to have this opportunity to speak both to the Boston audience and those of you who are connecting from other parts of the world. So the topic today is collecting visualizations. I'm going to speak for a while, and then Dario is going to show a very interesting demo of a project that he's built out of some of the same material. The project is called Kovic. That's an acronym for COVID-19 Online Visualization Collection. And we do have a website, kovic-archive.org, which has all the information that you need and leads to the visualizer that I'll be demonstrating today. So I urge everybody to go and take a look at it and play with it when you have the opportunity. So this collection is a set of visual representations, and it's intended very specifically for teaching and research purposes. And what makes all of these representations similar is that they all point to the same phenomenon. They all point to the COVID-19 pandemic and its effects around the world. The team of people that have put this together include myself. I've done a lot of the organizing and definition and legwork. My close collaborator, Hugh Dubberly from the Dubberly Design Office in San Francisco, who also teaches at the Information Design and Data Visualization program at Northeastern, and Professor Paula Ciccarelli, who's head of the Center for Design there, has provided us with a great deal of support and is essentially hosting the project right now. We have a group of very talented programmers who've developed the Airtable application and the visualizer, and the website is developed by Liehua Ying Yang, former student from Northeastern. And the metadata was done initially in collaboration with Yishuan Zhang. So this collection was created starting in March of 2020. Many of us were confronted with strange things going on in March of 2020. And initially, what impressed me, and I'm sure impressed many people, was how many visualizations were suddenly appearing about this event. And that initial collection was really a matter of copying links into a spreadsheet. Those of us who are online all the time, we're suddenly seeing all of these things and trying to remember where they were. We started making lists, and that list developed into a set of metadata. So in addition to copying that URL, we were copying titles and publisher and language and country and publication date. And then I put out a request to a lot of former students and colleagues, people around the world that I'd had contact with. And I started asking them if they could send me a link to any web page that contained some kind of information visualization, as long as the intention of that visualization had something to do with the COVID pandemic. And so it started to become not just the American sources or the French sources. I was in France at that time, but we tried to get a lot of material from different points of view, since this was quickly spreading, as we know, around the world. And we were looking for both qualitative and quantitative visualizations. Quantitative visualizations of pandemic data, things that clearly were related to numbers or statistics that had been generated from the numbers, like these examples we see here from Germany, from France, from the United States. But we were also really looking for qualitative visualizations, anything that was designed to explain the scientific or the social aspects of the pandemic. And there's been a tremendous amount of creativity in that area, both on the scientific side and on the social side, absolutely. As we built the collection, we tried to develop a set of categories, and this was done essentially heuristically. Once you had 100 or you had 200, you started seeing patterns as to what these were about. And the intention was to create as few categories as we could and still be useful. So we had these high-level ideas of things having to do with medical or non-medical, having to do with risk. And then within medical, we divided it between magnitude and supplies, supplies being things like PPE and masks and vaccines that are specifically medical. And the non-medical areas such as economic and social, and actually for a while in 2020, there was a lot of things about environmental impact, though that seems to have more or less evaporated. And then on the risk side, we were both looking for material about the history of pandemics and how that taught us something about what was going on. Also, future models. There's obviously, people are aware of many types of models for predicting what will happen next week or next month. And there was a large amount of focus on the concept of flattening the curve, particularly in 2020 and early 21. And then in addition to that, we were looking at examples that were really focused on transmission and infection, more general biomedical research. And again, during the first year, there was a lot of articles about advice for the data visualization community, what you should or shouldn't do. But the collection is really about the figures. That is the subject here. And we collect it in two phases. First, we collect article metadata. So we identify an article that has the figures, and we identify things such as publisher and language, source type, the data was recorded, as well as the data was published. And then we look at the individual figures in that article, and we record separate information on each figure, its visualization type, the technique, interaction technique per figure. For each one of these, we try to collect a page image, either a long scroll that is literally an image of that page, or a PDF. If it's an academic article, it's often also available as a PDF. So we collect that, and then we cut out each individual figure in the article so that they can be saved and classified. So we've got both the page image and the figure images, and I'll show you how that gets used. And some of those figures are static, and some of them are recorded as MP4 as dynamic. And that's really a call on the part of the person who's doing the recording. If we feel that recording it as an MP4 is really going to help somebody understand how this figure works, how it was intended to work. So we've got about 3,200 articles and web pages. That contains actually about 12,000 figures since I made this slide. And the most common topic for all of these figures, or source rather, is the news media. That's the largest of the parts of the circle here. We've also got NGO material and peer review publications and things from government sources, as well as these others. And then on the subject side, the most common subject is medical magnitude, as well as medical supplies, these two orange colors you see over here. We've got a lot on transmission and infection, and social and economic subjects as well. So let me switch over to a demo of the visualizer itself. So this is live, so if it starts spinning, you'll understand that's what happens when you do live demos, right? We've got each of the individual figures, and by default, they're sorted chronologically, the most recent first, but we can flip that around. We can take a look at the oldest ones first. And one of the things that we see when we do that is this is the original flatten the curve diagram, which was actually published in 2007. So we do have some things that actually predate the pandemic here. We can also take a look at this by language. So if we want to see only figures that are in Chinese, we can choose Chinese, and now we'll see figures where the language is Chinese. And likewise, we could pick a language such as Spanish, which is going to be shared by a lot of different countries, and we can see the material not only from Spain, but also from Puerto Rico and from many of the countries in South America that show up. If we take a look at the subjects, just to show how you can combine several of these filters, if I pick non-medical economic as the subject, and let's say, let's just look at material from the UK, we'll see a set of figures from The Economist, from Financial Times, The Guardian. And one of the things that I think is interesting when you do this is you begin to see certain national styles in terms of which of the visualization techniques are used and what types of things are being visualized in one country as opposed to another country. We can also take a look at visualization type. We've got almost 30 different visualization types here. I'm going to choose cartogram because I'm real fond of cartograms. And I think it's interesting how the cartogram has developed more recently, largely because a lot of the data in the United States and in some other countries that are divided by state are reported by state. And so it's easier to use color, as you see here, or individual bar charts or line charts or area charts to show the variation from one state to another. And while most of these are the US, we have one here from India, and we've got a number from the cantons of Switzerland and some from the departments of France as well. So it's interesting to see how that gets used. You can also search for individual text words. And what we're finding here is the word in the title of the article. So if I'm interested in looking for articles that have to do with vaccine, I can look at them most recent first, or I can flip that around and take a look at it being older ones. So we can start to see what some of the images were about vaccines starting as early as April of 2020. One of the things that is interesting in this is that you can begin to see some patterns in terms of what people were focusing on and how they were visualizing it. This is an article from the New York Times from the very end of April 2020. And the topic here is how long will it take for vaccines to be produced? So here's another example of recording something so that we can see how it works. So that's an individual figure. We can also look at all of the figures in that article. So you're looking at the peers within that article, right? And while you're looking at this, these will also play. Or we can look at the page image so we can get a context of where those figures show up. Or we can visit the article itself. So in this case, the New York Times article is still live and we can get to it as long as we have a subscription or we've got some other way of getting into the New York Times. Right? So one of the things that we've tried to do by recording these is make available for research purposes those images that you might not be able to get to either because you don't have access to the site or because the site has disappeared. So for teaching purposes, I hope this will be useful for a long time to come. One other thing I wanted to show on this demo is some of the article technique that we've marked in the metadata. So we've got things that are specifically dashboard designs, and we've also got scrolly telling, which is an interesting popular thing that's been going on. And data update, we've got about 500 of these. If I pick data update and I apply that, I'm looking at figures that for the most part are actually being driven by data on a daily basis, right? So the article itself has data update. And you know, a good example of that, this is a very recent article from the Washington Post. If you look at this figure, it shows that the percentage of Omicron is 92.1, and that was true on the day that we recorded it. If we actually visit the page, we'll have live data. So this is the figure for today, right? And it's an interesting problem, you know, from the point of view of recording these. We record them on a particular day, and so the material that you see in the figure is from that particular day, though many of them are actually designed to update on a regular basis. So let me switch back to a short presentation on some ideas of how this could be used. As I said, it's intended for research and teaching. And so one of the things I'd like to do here is give 3 examples of how I think it could be used. And when I say research and teaching, I don't mean it has to be limited to university classes, but things that you could do accessing this that might help you in your thinking. I'm going to do 3 examples comparing a variety of visualizations on one topic, looking at some transformations from academic figures to news media, and an example of a kind of mood board for scientific illustration. So let's take as a topic, just as an example, airborne transmission of coronavirus. This is obviously something that a lot of work has been done on in the last couple of years. And there's quite a variety of examples. So I'm going to go back to the demo, and I'm actually going to do some searching on these 3 words as a way of finding figures that might have something to do with aerosol transmission. So I'm going to take a look for aerosol. And you know, we see a combination of scatter plot and very dense scientific illustrations, but we also start to see different types of isometric representations of physical space and ways of showing how things move from your nose and your mouth. Different types of 3D simulations that break down the theory. And if I look for airborne, you get some diagrams that are showing how things are laid out in a house. Other types of really computer-generated 3-dimensional space. And if I choose another word such as ventilation, we get diagrams that I think only if you were in different types of engineering and sort of combination of engineering and architecture would you see these types of diagrams, but now we see them quite often. And another good example of this in terms of what we have and also the way we've recorded it. This is a scrolly telling example from the New York Times. So when you have such a long piece like this, we simply went through the article as an animation, and you begin to see how the technique itself is being used to connect the text and the type of visualization that's going on. So having done that type of a search, someone who is interested in this could put together a collection such as this, and you can begin to see patterns. Some of these are really focusing on the literal representation of the particles in the air. Others are using different types of computer simulations to show how that would move around. And then say all the way over on the right, you see a more traditional form of scientific illustration that abstracts these ideas. The second example is transformation from academic figures to news stories is something that happens all the time, but it's certainly something that is happening a lot right now. Here's an example very early in the pandemic, right around the time we started this, someone in the New England Journal of Medicine published this article about how long the virus was going to survive on cardboard and metal and paper and so forth. Copper, cardboard, stainless steel, and plastic. And that generated a number of interesting visualizations. This is one from Turkey where it shows how long the virus would stay on different surfaces, including in the air, on surgical gloves, and there's a little call out down on the lower left as to how long it would remain on your beard also. And then there was this animation that showed up in the New Yorker, which was taking essentially the same information and turning it into an animated GIF. I don't know if any of you had this experience, but this inspired many people to leave their delivered groceries outside on the front step for an entire day. Right? Another example is an article that was published by a group from the Federal Reserve. And this is a rather complex looking scatter plot that is showing you that has introduced the concept to me of NPIs, non-pharmaceutical interventions. Apparently this is a public health term for not taking drugs, but doing something to help eliminate a disease. So everything that we've been doing is an NPI, and they were trying to show how NPIs during the 1918 influenza epidemic had long-term positive economic effects in certain cities in the United States. That same thing was redrawn by The Economist using these two colors and making the label stricter policies and more lenient policies rather than referring to NPIs. And in the New York Times, they actually flipped the chart around and used color to mean different pairs of cities that were being discussed in the article. And the last example on this is introducing race and ethnicity data. So this happened largely as a result of two NGOs that were publishing. APM Research Lab first published a set of data that showed the difference between the percentage of population within a state and the percentage of people who were dying in that state based on the racial categories that we have in the United States. So this shows how wide that difference is in using a dumbbell chart in different parts of the country. And then the Economic Policy Institute published another set of bar charts that were specifically data on Black Americans. And they used this form of light blue and dark blue to represent Black and white data throughout the entire piece. And there were about 25 of these. It was kind of numbing to look at, but the data was all very, very provocative and very timely right at the beginning of June of 2020. The Financial Times published an article that was based on a combination of this data set. And what's interesting, if we take a look at the one on the left, they took this chart, or they took the data from this chart, turned it into a 100% bar chart. And then they also ordered the, the types of work from largest to smallest so that it was easier to scan and also to see the relationship between the size of the bars and the size of the 100%. And for the dumbbell chart over here on the right, they took the difference between the bars that you see on the left and the original one, and they used the dumbbell technique to use that space between the dots to really show how diabetes and hypertension and obesity, how there was really a large difference in the prevalence between the white and black population. And then for the last one in that article, they took two of the figures from this and combined them into divergent bar charts with the headline that the 12.5% share of the population was half of the share of the deaths, or in other words, the deaths were twice as large as the share of population. And they took two different sets of bar charts in very different parts of the original report, and they combined them into a better story over here. On the mood board side, like, what does a coronavirus look like? I think we all understand that you actually can't see a coronavirus, but we've got scientific data that is being used to make these kinds of visualizations. You begin to see the range of concepts and ideas that people have come up with from the classic CDC example that you see on the upper left to one which actually combines an electron microscope image over on the right, different types of representations of the surface, as well as cutaways, and all of us recognize what a Lego looks like, right? So this is a great metaphor example over on the far right. You think about trying to visualize molecular structure. I've never seen, or before this, I had never seen this type of molecular visualization. I'm particularly fond of the dancing spike proteins over here, which come from the Max Planck Institute. But you can see this variety of techniques. And I imagine if you're in the scientific community, you might have an opinion as to whether the ribbon visualization or the full 3D visualization or these amazing paintings made by someone at Scripps named Goodsell, which you see over on the right, are the most effective way of representing this type of a structure. But sometimes I think that one side effect of the pandemic may be that 15 or 20 years from now, there are going to be an enormous number of molecular biologists who first saw what the molecular structure of coronavirus was when they were 5 or 6 years old, and they've been dreaming about it ever since. And then the question of how do you represent a mutation has become really pressing recently, and the variety of ways this is being shown is astonishing. From very abstract, this example from the Washington Post on the lower right, to this incredible detail of the code name for each of the individual molecules on the spike protein that you see over on the left. How do you visualize the principles behind that science? You can do that with the kind of narrative sequence you see on the top, or with an animated GIF, or you can use what I assume is fairly high-end 3D animation and show how individual calcium atoms batter the side of the spike protein. There's also a lot of examples of this kind of a vertical visual narrative. This comes, and you think about it, comes from the nature both of the way we've designed screens now, as well as the newspaper column. And I'm going to leave you with this one just before I turn it over to Dario. This is from a group at the Children's Hospital of Philadelphia, and personally nominate this one for an Academy Award.
Coronavirus. Like many viruses, it uses a protein on its surface to attach to and enter our cells. Antibodies that fit onto this protein can block the virus from attaching. Coronavirus mRNA vaccines teach our immune system to make these antibodies. How do mRNA vaccines do that? mRNA is a genetic material that instructs our cells to produce proteins. The mRNA in the vaccine is wrapped in a layer of fat particles that protect it and help it get taken up by specialized cells of the immune system called dendritic cells. Once inside these cells, the mRNA does not enter the cell's nucleus or interact with DNA, but remains in the cytoplasm with other mRNA molecules, waiting to create the enzymes our body needs. When ribosomes read the vaccine mRNA, pieces of the viral surface protein are made. These pieces are then displayed on the surface of the dendritic cell. The dendritic cell travels to a nearby lymph node, where it presents the surface proteins to other cells of the immune system. Some of these cells, called helper T cells, train B cells how to make antibodies that will fit perfectly onto the surface protein of the virus. Other cells stimulated by the protein pieces, called cytotoxic T cells, can kill virus-infected cells. Now, when the coronavirus tries to infect us, our immune system is ready, immediately recognizing, neutralizing, and destroying it before we ever even have a chance to become sick.
So I think they've been watching a lot of Star Wars films myself, but they did an awesome job of turning that into a very concise narrative with, I imagine, a lot of computing power and molecular data behind it. So we've got these locations that people can look at later. I'm going to turn it over to Dario. I had the great opportunity to meet him remotely initially, hearing about his work and seeing some of the things that he was able to do. And then we again collaborated remotely for a while, sending data back and forth. And then we had the pleasure of actually teaching together last month. So we've seen each other not only on the screen, but in person. So I'll let Dario introduce himself and show what he's done. I can unshare my screen here.
Sure. Thank you, Paul, for this beautiful introduction. My presentation is really visual and it's more a demo. This is my website, just to tell you that I'm working between data visualization and digital humanities, and I like to create immersive data visualization. This is the last one I created for Ars Electronica 2021. But mostly I am a postdoc of the MetaLab, and with the MetaLab, this lab directed by Jeffrey Snapp at the core of Harvard University, we have a beautiful project in collaboration with the Harvard Art Museums, which is called Curatorial Agents. And the idea is to work with the digital collection that this museum has. So basically, when I met Paul, I was working on this project. I mean, we were trying to visualize the entire collection of the museum, and it was a tough project. I mean, it is. And but finally, with the help of the Yale DH Lab and Douglas Duhaime, we were able to create the first visualization using this open access software called Pixplot. And Pixplot allowed us to show at the same time more than 200,000 images from the collection. So basically, I can show this one, and then I will move to the COVID project, and so it's just beautiful because it's a graph, it's a network, and basically you can zoom wherever you want, and you have pictures on the same subject clustered together. So, for example, this part is about pottery, and we can zoom another part of the visualization. Here we have the coin collection, and so basically, when I met Paul, I had let's say the technology to solve his problem, and so we decided just to apply this kind of visualization to the collection of his project, his collection of COVID-related images. So I can spend a few more words on this. This is a slightly different version that the Yale DH Lab produced. It's called Trails, and it's still private, but I think we will publish this software in the next month. And basically, it's a little bit more light than the other one, just because we are using a sampling to show the images you have behind, and this is just because of great limitation we have on laptops, on computer, and so on. So basically this is another version, but let's say the idea is always the same. We try to visualize a large collection of images using a metric of similarity. Technically, we are using convolutional neural networks based on an ImageNet 2012. So the idea is that we are able to transform images in vectors, and once we have vectors, we can compare vectors with dimensionality reduction and create this two-dimensional projection. So this is the technical process behind. What is interesting is that it's more working. I mean, this kind of trained collection is more for photographs, but astonishingly, it works even for data visualization. You know that we have this mystery behind artificial intelligence, but what it happens is that we had different classes associated to the images, and basically the algorithm is able to find a kind of similarity, a clustering based on traditional photographs. So this is the interface, which is also public, but it's private website, of course, because we are still working on it. We can work with, we can play with a few parameters. We can change the number of previews. We can change the size of previews. We can change even the margin of them. And this is very interesting because at the same time we can grasp the size of the collection, because correct me, Paul, but if I'm not wrong, we have more than 12,000 images in this collection, and so we can study them from a distant point of view. And what is, I think, very interesting from this kind of visualization is that we can get clusters, so we can get similarities between these images. And I will show some areas that I found interesting just because I started an exploration. The idea is not to have something scientific oriented, but just bring a tool in which users can see what they want to see. It's just a tool for exploration. So for example, just previously I was talking with the other host about this area, and you see, if you zoom at the bottom of the graph of the network, you have all images related to geography. So basically you have maps. You can click on them, you can have details, you can click on the title and go directly to the article. So this is even nice because we try to build up all this chain of zoom from the whole image to the original article. And so we have this area, which is interesting. We have another area, which is pretty obvious. So we have a lot of line charts, if you see them. You can open one of them. Another area, which is very common with this kind of a visualization, is related to bar charts. So here we have some bar charts here. And this is, I mean, this is what you can get at the first sight just by exploring. But for example, previously with Paul, we had this conversation about, I think it's a small cluster here, and it's about cartograms. And so you can see that the algorithm was able even to recognize somehow the cartograms that have been collected in this collection. And so we have different typologies, we have borders between different typologies, but we have even forms. For example, there was this area that attracted me just because everything was related to circles. So in this area, we have visualization that are classified as circles. So my presentation was just in support to the wonderful work by Paul, and I'm very happy to have helped him with this kind of visualization. I think we have still 15 minutes, and it will be nice to answer your questions and discuss with all of you. Thank you.
Awesome. Thanks so much, Paul and Dario. This is amazing. So we have a couple of questions coming in. Mike, I could just ask it for you. What do the colors of the dots represent in this map?
I mean, the colors are just sort of a representation of the images. So it's a sampling, it's an average, it's something related to a particular image. And that was a way to solve the computational weight that was existing in the previous version. So instead of showing bitmaps, we are just showing colors and offering this kind of a sampling, but the color is really related to the most relevant color of the image.
I see. See, I had one. So I was wondering, so clearly in this time of COVID, there's been a lot of complex and advanced visualizations kind of in the public space now. So have you noticed whether this has had any impact on, I guess, the culture at large and what types of visualizations are out there now?
I would offer a couple of examples, and I don't have any data, right? So I can't say, oh, it's changed this way or it's changed that way. But my impression is that many people have had the experience, either by reading or by working themselves with some of this data, of how lining things up by time and using linear and log scales can really show enormously different views of the same data, right? So John Burns Murdoch's line chart that he developed, I think it was in April or May of 2020, where he took all of the case numbers and he lined them up, rather than lining them up chronologically, lined them up based on the number of days since the first case within a country. That demonstrated to a lot of people that there's ways of manipulating this data that would make it clearer. And then also the use of log and linear scale for many of these line charts. It's not as though any people invented this, but I think it's just had never really been demonstrated how important those kinds of choices can be. I think scrolly telling was already happening, but as a way of combining narrative text with animation, it has been used a lot, right? And again, I don't have any data, so I can't tell you whether it's been used, 5% more or 50% more, but it clearly has had an impact on the way in which many of these stories are being told. It's interesting to contrast the 2-minute video approach, which many news organizations use, with the scrollytelling approach, which clearly involves more active cognition on the part of the person who's reading it.
Thank you. Aditya, you had a question.
Yeah, I was wondering if today someone finds a new visualization, is there a way they can add that to the dashboard, or what's the procedure like?
Well, at the moment, the procedure is there is a feedback link, which is just a feedback email, and you can send it, and you can also just send me mail. Essentially, the way things get added is that either people send them to me, or I find them, or a couple of the people who are actively working on this find them. But we have not designed this for crowdsourcing. That's not a philosophical issue. It's more a technical issue. Adding that would add another level of technical management that we just don't have the resources for. So the short answer is send it in, and if you don't know what my email is, there's a feedback link on the website. Just send it there. Thank you.
I have one more question. So when you were curating these visualizations, so many of the published ones had some error, or they had some manipulation with scale, which were published in local newspapers. So when you put them on the Kovic dashboard, does it go through a vetting process, or that's also like open for public, that if anyone can flag and say this visualization is misleading or something like that?
I think that's a very interesting project, and it could be a very interesting additional piece of metadata to associate with these. But at the moment, we're not evaluating them for accuracy. In many cases, we can't even read the language that they're in, and we have no way of checking the data that is behind it. We're only aware of a few examples that in the news have been identified as questionable, right? But no, everything here is being treated as a visual phenomena, not as a piece of accurate data. And I should make it clear also, we're not collecting data, right? There are really smart people who are working very hard on collecting the data, and there's many different sets of data around the world. And I hope those people are doing a great job. We're collecting the visualizations.
All right, Mike has a question. The question there was, any tips on how to search your charts for visualization specifically?
And yeah, in fact, there is no specific way of doing that using the visualizer, the program that I was demonstrating. In the Airtable application where we store everything, there's a kludge. I simply put like, see this ID number and see that ID number in there. So we didn't find a way of linking the articles that were referring to one another in the visualizer itself, but we've got lists basically, and the other way of doing it is looking at these things chronologically, and you can sometimes see that the things that are published within a few days of one another are talking about the same topics. Good question. It could be very useful.
Next one is from BC. BC, do you want to speak to your question?
Yeah, I was wondering if you have observed any interesting insights with regards to differences among countries, languages, like all different countries publish different kinds of viz, and they're telling different, I guess, similar but different stories. I don't know if you have a chance to take a look at that angle.
Yeah, I think that is a great question, and I think it's one of the areas that you could explore. Anyone could explore by using this collection. My impression is that if you compare one country to another country, depending on which countries you're comparing, you will see distinct differences in style, which are cultural. So if you look at the examples that are from Germany and you place them next to examples that are from Mexico, you'll see that there's differences in the way in which color is used and the relationship between type and image. You'll also see differences between examples in certain publications that really help you understand what art direction is all about. But I think one of the things that my impression is you won't see a big difference in the types of visualizations that are being used. As Dario was pointing out, there's large parts of the cloud that are line charts and large parts of the cloud that are bar charts, and you'll find those in all different parts of the world. But in terms of style and also which parts of the data get visualized, you could probably find some interesting differences from one culture to another.
Thank you.
And talking about culture and languages, we had a similar question from EB. EB, do you want to read your question?
Since you're covering all these different languages potentially and not necessarily speaking very many of them, how was it trying to categorize these images in all the different ways that you have with all these different languages involved? Thanks.
Yeah, so that's a very good and fair question, and always to the best of our ability, we've tried to use two things. One is finding native speakers to do the categorization. That's absolutely the best. And in often the things that are in languages I don't understand have been sent to me by people who do understand that language, and so I can query them. But when all else fails, we use Google Translate.
Well, it's amazing. Thanks.
All right. Any last questions before we call it a day?
Let me give one last point out there. So Dario's work, as he was presenting it, was really another way of looking at this image collection, rather than the kind of classification that we were creating. The algorithms that they're using of visual similarity were bringing things together in the same way you might look at art. We're also very interested in looking at this chronologically. If anyone is really good at doing timelines and would like to take a set of data like this and with a lot of visual material and turn it into some kind of a way of looking at it through time, that would be very interesting. And overall, we're trying to find different ways of both visualizing overall in the large and exploring in the specific, the different parts of the collection. So my hope is that there's people much smarter than me out there who can come up with some ideas, and we've got interesting data for them to work with. So I want to thank Dario for joining us today and showing that really great project that he's working on, and thank everyone from BostonCHI for giving us the opportunity to share this with folks.
All right. Thank you both so much. This has been awesome. And thanks everybody for joining us. I guess we'll see you next time.
That's right. Have a good lunch.